Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 8 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2379. Minimum recolors to get k consecutive black blocks. Okay, so let's read the problem statement first. So you are given a zero index string blocks of length n, where blocks of I is either W or B. Okay, representing the color of the ith block. The characters W and B denote the colors white and black respectively. Okay, you are also given an integer k, which is the desired number of consecutive black blocks. Okay, in one operation you can recolor a white block such that it becomes a black block. Okay, we have to return the minimum number of operations needed. Okay, minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. Okay, so now see this example number one. These are the blocks given to us, right? W means white, B means black. Okay, so k7, that means that we need 7 consecutive black blocks. Okay, and we have to find out the minimum number of operations needed such that there is at least one occurrence of 7 consecutive black blocks. Okay, so here uh, see, this is white. Okay, so I can paint it to black. Okay, this is already black, this is already black. I can paint it to black, I can paint it to black, and this is already black. Okay, so in this window, if you see carefully, total how many? Total 6. Okay, we need 7, right? So include this one as well. Okay, so here this is at 0 index, this is at 1 index, this is at 2 index, this W is at 3 index, this W is at 4 index, this B is at 5 index, and this B is at 6 index. Okay, same way these are at 7, 8 and 9 index. Okay, so total length of this blocks is 10, right? And if you see this window, okay, first window, okay, until here. So in this window we have 3 whites which we can change it to black. Okay, so if I change this to black, these two to black, and this to black. Okay, so in this case I will get one consecutive 7 black blocks, right? One occurrence. Okay, I will get one occurrence of 7 consecutive black blocks, right? So how many recolors I'm doing in this window? So I am doing total 3, right? Total 3 recolors in this window. Okay, so right now 3 is my answer. Okay, now next time if you move to this one, okay, if you want to include this one, so you have to move one step forward. Okay, so then you have to start from here, okay, to check this window. Okay, so previously you were checking this window, then next time you want to include this item, then you have to move forward, right? So here you are adding one element, and from here you are removing one element. Okay, so this is what you are doing. So size is fixed, size is nothing but 7, right? So how I'm going to get the size here? So it is very easy now. So size is going to be, see, in the previous window, if you see, until here we took that window, right? Until here. Okay, so in the previous window, right, we need 7 size. Okay, so previous window 0, 1, 2, 3, 4, 5 and 6, then 7. Okay, so in the previous window my starting point was this. Okay, let's say this is my left, and my ending point was this, right? So that is why 7, 1, 2, 3, 4, 5, 6, 7. Okay, so that is the size, right? 7 is the size that I need. So here I can do one thing na, r minus l plus 1, r minus l plus 1. Okay, if it is equal to k, okay, that simple means that this is one valid window. Okay, so now in this window, you know that we are total doing 3 colorings, right? Here in this particular window, right? Now next time if I'm moving forward, so my right is moving to this 7, okay, and my L is moving to this one. Okay, L is moving to this one. So here 7 right minus L is at 1, so plus 1, again I'm getting the size as 7 only. Okay, which is equal to k, right? Size is fixed, right? So I can use this formula to check the window size every time. Okay, now my window is also moving one step forward, so here we have to add this element and we have to remove this element. So here in this example, if you see, okay, so what is this example here? We have W, then B, then we have 2W, then we have BB. Okay, so this is one window, right? 0, 1, 2, 3, 4, 5, 6. Okay, so this is the first window, right? So size is 7 only. R minus L plus 1, so size is 7 only. Okay, so done, clear? Okay, so here now next time if you move one step forward, so here you see after that we have W. Okay, so here in this window, okay, so I am adding this white. Okay, so I have to recolor it, so my color count will be incremented to 4. Okay, but here I am removing this W, right? Because my window is moving forward, so I have to subtract it, so it will again become 3 only, right? So again in this window, if you see the total colors that we are doing here in this complete window, see 1 2 3 3 recolors. Okay, again 3. Again, if you move forward, then you have to subtract this and include this. Okay, but here it is black, so we don't need to subtract. Okay, only if it is white, then we have to subtract. Okay, this is nothing but a classic sliding window approach. All right, so now same here, case 2. So that simply means that 2 to size here, so one color. Here in this window also you need one color, here in this window also you need one color, but here in this window you need no colors, right? 0. So that is why output is 0. So we need to change, return the minimum output, right? So done. And yeah, that's it. So here these are the constants size. Okay, some very small, and blocks of I is either W or P. Okay, and K value is always less than equal to N. Okay, from 1, right? Now let's write the code. So it's very simple. First just create one variable left and set it to 0, and then we have to calculate the bytes only. Okay, so here number of bytes, so and num W you can write. So initially set it to 0. Okay, number of bytes, and then number of recolors. Okay, so here number of recolors are num r. Okay, so here we need to find the minimum value, so just take the max value for this. Initially integer dot max underscore value. Okay, now after that you have to move the right pointer only. So here for int right is equal to 0, right is less than n, and right plus plus. Okay, so we haven't created any variable n, right? So just write here blocks dot length. Okay, or you can create a variable if you want. All right, so done. So here once this is done, then after that here you have to just increment the number of bytes if block at right pointer is white, right? So here if blocks dot char at right index. Okay, so if it is white, okay, so capital W, so in that case, okay, if it is capital W, then in that case you have to just increment the number of bytes. So here number of bytes, so increment it. Done. So here you are incrementing the number of bytes, right? Now you have to check one more thing, that if including this makes a valid window of size k or not. Okay, so here I'm just going to write if the right minus left plus 1 if is equal to k. Okay, if it is equal to k, that simply means that it is one valid window right now. Okay, then we have to update the minimum. Okay, so we have to update the minimum. So here number of recolors that I did in this particular window, so here we have to update it as math.min of uh, this number of recolors. Okay, maybe in the past we have calculated some value. Okay, and here number of bytes. Okay, number of bytes. So this is what we need to do. All right, and now this is the, and also here one more thing that we need to do here. We have to decrement the number of bytes if a block at left pointer is a white. Okay, so here if we are moving forward, right? So in that case also we need to check now if blocks dot char at left. Okay, at left. Okay, if it is equal to W, then we have already recolored that in past and we have counted that. Okay, so now we have to just decrement that count. Okay, so number of whites. Okay, this is for future operations. Okay, so I have decremented it, and now once this is done, then we have to move the left as well. Okay, left plus plus. So done. Okay, now in the end you have to just simply return the number of recolors that you did. Okay, so here return number of recolors. Okay, num r. That's it. Now let's run the code and see if any code issue. We'll try to fix that. So the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted and the time compressed is going to be of n, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.